do an example of this, it would look like something like 3 plus 2i would be a complex number. That's all it looks like. All right, so we said that I was the square root of -1. And kind of like what Mr. Patton just said when he came in, right? If we have I squared, that's the square root of -1 times the square root of -1, right? And when you multiply two things with the square root part goes away. And so you're left with -1.
Would it not be positive though, since it's two negatives times each other?
No, because at that point you're just getting rid of the square roots. So I squared is equal to -1. And then if we do it to the third power, right? So that's like doing -1 times another I. So that would be equal to -I. And then I to the fourth, what do you think that one would be?
Negative.
Nope. It's like I squared times I squared. So -1 times -1 is +1. So you need to know these four things. So you have I squared is -1, I cubed is -I to the fourth is 1. And then as the powers get bigger, this pattern just repeats.
Why is I -I?
Yeah.
All right, so if you think about it, you can write I cubed as like I squared times I, right? That would be the same as I cubed. I squared is -1 times another I. So you get -I. Right, so typically, there's going to be times we work with complex numbers that you're going to get like larger powers of I that you have to simplify down. So the easiest way to do that is, let's say we have I to the 23rd power. So you're going to divide it by 4. Like not on a calculator, like actually divide it out because you need the remainder. So 4 goes into 23 how many times? So you get a remainder of 3. That means that I to the 23rd is equal to I to the 3rd, which we know is equal to what? -I. Right, so you divide your exponent by 4 every time. So then 4 times 5 is 20, so that's going to be the smallest thing that goes into 23. And then subtract it, get your remainder. Your remainder becomes your exponent.
Wait, I don't see why you would take 4 and 23.
Because it repeats after 4, like after 4 exponents. Because we have I squared, I to the 3rd, I to the 4th. So then like I to the 5th is just I to the 6th is I squared, I to the 7th is to the 3rd, and so on. So after every 4 it repeats.
So you can only go up to 4.
Yeah, so you always divide by 4. Yeah.
I like that word always. It's very different.
Yeah, it's very rare, but in this case, yes, it's always a 4 here. Right, so then if we do, let's say, I to the 50th. Right, so again, we're dividing by 4. So 4 goes into 5 one time, which gives you 4. And 10, it goes into 10 twice, which gives you an 8, which means your remainder is what? 2. So that means our exponent is 2. And I squared is equal to -1. All right, let's do one more. Let's do I to the 12th. So we do 4 into 12, which is what? 3. So we get no remainder. When there's no remainder, it is always I to the 4th, which is equal to 1. All right, so how do we feel about the simplifying? Divide by 4, find the remainder, and then use what you know about those first 4 exponents to get your answer.
When you have a remainder of 1, is the answer the square root of -1?
You can really just leave it as I. Yeah. We really just use that square root of -1 part to figure out what the other higher powers are. But yeah, you would just leave it as I to the first or just I. All right, so let's do some math with complex numbers. So we can add them together. Right, so let's say we have 2 plus 5i plus 3 plus 4i. So I is technically just a variable, so you're just going to combine like terms, like we know how to do. So you add the real numbers together, so 2 plus 3 is 5, right? And then 5i plus 4i would be what? 9i. That's it.
That's all?
Yeah. You just combine like terms. So like when you subtract, let's do, all right, so just like when we subtracted polynomials, remember we have to change the signs of both of these before we combine like terms. So we have 7 plus 2i minus 10 minus 9i. So 7 minus 10 is -3, and then 2 minus 9 is -7, there we go. All right, so -3 minus 7i, that's your answer.
Looks too good to be true.
It's really not. I told you guys it was easy.
Are they all this easy or?
Yeah.
Oh, okay.
So adding and subtracting, this is just,
Stick this out through the end of the year.
I know. I feel like you should add I feel like there should be another step to make this really hard.
no, we're going to multiply next.
Is that today or tomorrow?
That's today. We're going to get it all. All right, you foil.
Oh, okay.
Like, this is we're basically applying all the stuff we already know how to do to a square root of -1. That's it. There's one other teeny tiny little step, but it's really easy, I promise. It. All right, so 8 plus 7i times 6 plus 2i. So, we're going to FOIL. We know how to do that, right? Hopefully. So, we're going to take our first two. So, 8 times 6 is 48. Right, then outside, 8 times 2i would be what? 16i. Right, inside, we have 7i times 6 is 42i. And then 7i times 2i is I squared. All right, so what is I squared equal to? -1. So we're just going to replace that I squared with a -1. Right, so since I squared is -1, so that we have 48. So then we're going to do 14 times -1, which is a -14. Because we replace this with a negative 1. Then we combine like terms, and we're done. So 48 minus 14 is what? 34. And then 16 plus 42, 58. Done. See, that still wasn't that bad. The extra step was just putting in a negative 1. Which means you get an even shorter answer. All right, so then we're also going to divide. So let's say we have 4 plus 6i divided by 2. What do you think we're going to do here?
Divide the 4.
Yeah, divide both parts by 2. So you get 2 plus 3i. For my non-honors people, yes, that's it. We have a tiny bit more.
Yay. Who's in honors? Besides, my wife Will pays also.
I feel like no. Are we all in honors?
No, only like 5 of you.
Oh.
People that chose
Don't know why.
All right, so the rest of you, please just be quiet for just a second. No, it's still not bad. So, I is technically a square root, right? So, we can't leave square roots in the denominator. So, let's get rid of it.
Isn't that just
It's the square root of negative 1. All right, hold on. I'm going to show you how to do it. So, when you have to divide something like this, you have to multiply by the conjugate. Which means you're going all right, so you're going to take whatever's on the bottom and you're going to change the sign in the middle.
Where does the bottom come from?
That's part of the problem. It's given to you. Yeah.
Oh, that's just given.
Yeah.
Oh,
So like this is your problem.
okay, I thought it was, I thought
Yes, this is a division problem.
that it was a continuation of our last problem.
No, new problem.
Where did those numbers come
No, new problem.
from? Okay.
All right, so you're going to multiply by the conjugate, which is you take whatever's in the denominator, change the negative to a positive, or if it's positive, make it negative. Just change the sign in the middle. So we're going to multiply by that on the top and the bottom. So then you just FOIL the top and bottom. Huh?
This is taking a lot longer.
We haven't even done it yet. Like,
We still have to FOIL both of them.
oh no, it's the end of the world. It's really not. All right, so that gives us, let's see, 2 plus 6i minus 3i minus 9i squared on the top.
But that's just the top?
Yeah. Now you got to do it on the
Oh,
bottom.
like you're foiling. I was just.
Yes. And then on the bottom, right, that's going to give you 1, let's see, plus 3i minus 3i minus 9i squared. Sounded like a very violent hiccup.
I just have every day just one hiccup.
Oh man, see, no, like when I get hiccups though, like they hurt. Like it's terrible. And they only come out like when I'm talking, never like in a convenient time. At those I squareds become negative 1s, right? So then on top, right, you're going to have 2 plus 9, right? Which is going to be 11. And then 6 minus 3 is 3. Nope. And then on the bottom, right? So we have 1 plus 9, which is 10. And then the positive 3i, negative 3i cancel out. The goal is to get rid of I on the bottom.
Could you walk through that again?
Yes. So, whatever's in the denominator, you're going to change the sign in the middle and multiply by that on both the top and the bottom. So then you FOIL. So like you would have 2 times 1 is 2, 2 times 3 is 6i, negative 3 times 1, negative 3i, negative 3i times positive 3i is negative 9i squared. We take the I squareds and make them negative 1s, which means that that's going to be like adding a 9. So we do 9 plus 2 to get 11, and then 6i minus 3i is positive 3i. And then same FOIL process on the bottom, but then the reason we multiply by the conjugate of the denominator is because that's going to get rid of the i's. And then you've got that I squared, which will make that a whole number. So it'll cancel out I on the bottom completely.
Is that the final answer? Or is it-
Yes. You can leave it just like that.
But can we go further?
No. I mean, if they were all like divisible by 2 or 3 or something, you could reduce it down, but this is it.
This is easy. The hardest part is probably trying to get a little swoop on the eye. But that's it for me.
I mean, you can do them as regular eyes, but again, if I do it as just like 2 straight, then they start to look like 1s and I get confused. So I've just kind of had to adapt.
None of them look right. They look like L's.
Listen, it's fine. As long as, like, you don't have to put, as long as you can tell it's an I and not a 1, we're good. And as long as I can tell it's an I.
See, sometimes I forget to drop my eyes.
Yeah, you can't do that in math class.
Yes, I do.